Our last lesson for section 4.6 is using Descartes' rule of signs. And Descartes' rule of signs says you can evaluate the signs of the polynomial and decide how many positive real zeros we'll have, how many negative, and how many imaginary. First, let's figure out how many positive zeros. For positive zeros, all you want to do is look at the original polynomial and count how many times the sign changes. Now right now, in front of the x to the 6, we have a plus. So we go from a positive to a negative, that's one sign change. Then from a negative to a positive, that's two sign changes. Then a positive to a negative, that's 3. Then we stay negative the rest of the way. So we had 3 sign changes. So we could have 3 positive zeros. Or you could subtract 2 because we could have 2 imaginary. So we could have 3 or 1 positive zeros. Now let's look at the negative zeros. To figure out how many negative, the first thing you need to do is plug in -1 for all the x's. The shortcut method would be any power that is odd, change the sign. So x to the 6 is positive, and it's an even power, so the sign is going to stay positive. -2x to the 5th is an odd power, so change the sign in front, so it's going to turn positive. 3x to the 4th is a positive power, so an even power, so keep the sign. The cube is an odd power, change the sign. The square is even, keep the sign. X to the 1st is odd, change the sign. And the constant, always keep the sign. So now let's check how many sign changes we have. We have all pluses, and then here we have a positive to a negative. That'll be 1 sign change. This will be 2 sign changes, and then this will be 3 sign changes. So we could have 3 negatives, or always subtract by 2, 3 or 1. Now let's make a table to decide exactly all the combinations we could have. For your table, you're going to write positive, negative, imaginary, and then our total. And we're going to make all the combinations. The total number of zeros is the same as the degree, which is 6. So we'll always have 6 running down the total side. So let's think of any combination. If I could have 3 positive and a 3 negative, which would mean I would have 0 imaginary, because it has to always add up to 6. I could have 3 positive, 1 negative, and that would mean I would need 2 imaginary to total it to 6. What if I have 1 positive and 3 negative? That's 4. I would need 2 imaginary for it to total to 6. Or I could have 1 positive, 1 negative, which is a total of 2, which means I would have had 4 imaginary solutions. So these are the 4 possible combinations I could have for this example. Now try the monitoring progress number 9 and 10.